Well, this is a lesson on section 11.5 in your textbook. This is obviously chemistry. It's entitled Ionic Bonding and Structures. Ionic bonding and structures of ionic compounds. And I'm going to add a little bit to this as well. When ionic compounds form, there's a number of unique features to an ionic compound. One of the first things, let me turn this so I stay in the frame. One of the first things that happens, and that I'm going to put down, is that ionic compounds do not form molecules. We don't talk about a molecule of sodium chloride. We don't talk about a molecule of copper sulfate. We talk about a compound. In fact, what they do is they form what is called a crystal lattice. Now, let me try and show this to you, and it'll be better if I come in and show it. I have up here a model of a sodium chloride compound. The larger atom will be chlorine, the green, and the blue, the smaller, will be sodium. The reason is very simple. When sodium loses an electron, it becomes smaller. It goes to the previous noble gas. When chlorine adds an electron, it goes up to the next one. Now, this has magnets on it, but that's because when this becomes positive and this is negative, when the electron transfers from here to here, those two snap together and they hold together. But I want to show you something. Let's say I had another chlorine ion floating around, a negative ion. It could come up and it could do this. Now, my question for you would be, which is the original? Which is the real one? And the answer is it doesn't make any difference. You say, well, I was watching carefully, it was that one. Well, so what if it was that one or if it's that one? It doesn't make any difference. In fact, it could be like this. What's going to happen is you're going to form what's called a lattice. They will start combining together. And in fact, if I take enough of these and start building this, I will build a lattice. A lattice means a repeating pattern. And this lattice will actually be three-dimensional. In fact, I have it here. I'm not going to keep building it. This is actually what a sodium chloride compound would look like. So it does not form molecules. This whole thing is sodium chloride. You say, well, isn't that a molecule? No, because this could be the molecule. It doesn't matter which one I'm looking at here. It could be this. If you said that's the molecule, then what about this one here? And so this is called a crystal lattice. A lattice is simply a repeating pattern. A wallpaper is an example of a lattice. And I'm just putting that back the way that it was. So this is actually a real good picture of a sodium chloride crystal. If you look at it under the microscope, it looks like that. So that's the first thing. And one thing that should be noted, again, is that that positive ions always become smaller. Those are cations. Positive ions become smaller. Your book's going to ask about that. Negative ions become larger. Just think about it, and it makes sense. The second thing about ionic compounds is that they usually dissolve in water. Not always, but usually. By the way, there's other things that dissolve in water, but ionic compounds usually dissolve in water, and they conduct electricity when dissolved in water. This is a really important idea. We would do a lab on that if you guys were here with me, but you're not. So let me show you this. I have right here a conductivity tester. It's a light bulb, and if I stick it down into water, which is covalent, it's a molecule. It doesn't conduct electricity. We're going to learn molecules don't. But if I put a bunch of salt in this, I have my salt shaker, it looks like a little egg. I'm going to pour a bunch of salt in there and stir that up. This should conduct electricity now. I haven't put a whole lot of salt in, but when I put this on now, that light bulb is supposed to light up. Okay, that's not very good. Let me put a little more salt in, and it could be that the light bulb is bad, and if it is, I'll take out a light bulb here that I know is working, and we'll try this. I may show this to you in another video. It's also possible that that plug isn't working. Let me, real quick, sorry, I should have tested that first. I'm going to take a light bulb out of here. It's going to make the room a little darker. This light bulb I know is working. And it's kind of hot. Okay, let's try it now. Nope, still not lighting up. That is very disappointing. Let me try one other thing. This is just like being at school when things don't work exactly the way they're supposed to. We'll try one more time. Nope. Okay, well, I will do it for you in another video. I'm not going to spend more time with it now. Excuse me. But normally it will conduct, and I will get that to work for you. I'll show it on the next video. The reason that this happens, and we're probably going to run out of time here, and if we do, I'll just stop the video and do part 2, is that sodium chloride, when it goes into water, it has a positive and a negative end. And water molecules, which have positive and negative ends, the negative end is the oxygen side. Water molecules look like Mickey Mouse. They will actually attack and stick to the molecules, to the ions. And eventually they will break this bond. And what you will have is sodium positive charges and negative charge ions that are essentially free to move. And electricity is simply charged particles being able to move. So if you put into here what I was doing, a negative side and a positive side, the sodium will move this way, the chlorine will move this way. And that fundamentally is what electricity is. Lastly, ionic compounds usually are solids at room temperature. And the reason for that is that that bond